When it comes to evolution simulators, the simulation The Bibits by Léo Caussan is for me the very best. Running the software on my computer, I can simulate about 1,000 creatures at the same time. As evolution is just a numbers game, the probability for an interesting behavior increases proportionally to the amount of reproduction cycles per time unit. That is why I decided to program my own simulation that focus heavily on performance to increase the number of creatures that can live at the same time. Through reducing the visuals and movement to the bare minimum, together with implementing multiprocessing, I managed to increase the amount of creatures to 15,000 with about 16 actions per second of each creature. Another difference to the Bibit simulation is that my creature's brain is not a neat algorithm, but an algorithm that is based on collection of genes. Each gene represents a connection in the brain, but to save processing time, only those connections who have at least one input and one output connected are actually taken into account by the algorithm. Other factors mutate slowly as well. For example, the color of a creature, I call the creatures Pixies, is given to its offspring and only changes slightly every generation. So having lots of pixies with the same color means that they are all genetically very similar. You could say a digital species. Another difference to the Bibits is that creatures don't get the information where the nearest food is. They only get visual data of the surroundings and have to learn by themselves how to convert the visual data to movement to find the food. The colors of the pixies also indicate certain specializations. A creature with a high red value is better at processing meat, while creatures with a low red are better at processing plants. A high blue value stands for the speed when it comes to attacking at the cost of more energy consumption, while the green value dictates the amount of poison it produces, so how much damage it does, also at the cost of a higher energy need. If the blend count is kept at a constant number, the pixies evolve to survive with this amount of blends, and then evolution comes to a crawl, because the environmental pressure is too low. That's why I started to decrease the amount of blends when the creature's count reaches a certain target, to artificially create additional environmental evolutionary pressure. The brain of the pixies gets different inputs according to their genome. Possible inputs are eyes, so output that is high if something is in front of them. Ears, which are not tuned to a specific direction, but just output a signal if something is moving around them. And internal factors like the amount of health they have or the amount of hunger. At first, the pixies start with 5 random genes. If the brain outputs nothing, it defaults to action 0, which is moving in a random direction. Again, this is to boost the probability for useful mutation, which is faster than setting action 0 to just standing still. We can observe some pixies moving in a straight line. This means that the neural network has formed a connection between movement and some input. As they are formed randomly, most connections don't really make sense. For example, a connection between the health input that outputs a 1 on full health and the move right action don't seem to make sense. But if it gives them a survival advantage, because, for example, they come over more food than just moving random directions, then it will prevail. That's just the nature of natural selection. Some of the Bibits are larger than others. The larger they are, the more health they have, but also consume more food. If they activate their attack mode, they are also double in size. They can attack in 2 different ways. They can shoot in a chosen direction or walk into others if they have activated their attack mode. This is to allow different kinds of radiation. A few hundred generations later, they evolved to effective plant eaters. They move towards a plant whenever they see one. Let's analyze one of their brains. As this data is hard to read for a human, I scribbled interesting parts of the brain down as a sort of diagram. The first connection is the defensive connection. As it has negative weight, it forces the creature to not move east if there is a red creature east. As we already know, red creatures are good at eating meat. So this hints as it is a defensive mechanism against predators. The next connection makes moving upwards more likely the closer the creature is to the bottom. The next two are obviously for finding food, as it moves in the direction as soon as it sees food. As I would love to see the simulation improve, I made it open source, so you can visit my GitHub and download it yourself to improve the simulation or just play around with it. Thank you very much.